So our notes today, we're going to be looking at exploring measures of variability. Earlier this week, when we looked at our mean, median, and mode, we were looking at, that's called measures of central tendency. Basically, you're kind of looking at the center of your data. Measures of variability, kind of when we get into it later today, is basically we're going to be looking at how spread out our data is. And a lot of times you might be able to just kind of eyeball that, but this puts a value on it. And a lot of times, like if you're actually running like a study or something, you could very well have thousands of numbers. Like if you had thousands of people answering a survey, or if it's like a medical study, you might have thousands of samples from people. When you have a big data set, it's not like you can just look at it and be like, oh, this is really close together, or this is really spread out. So standard deviation is kind of like a way to kind of calculate and put a number on it. And it's a good thing. It lets you compare data sets. A lot of the examples we're going to look at today is like with sports teams or classrooms, but standard deviation kind of is a way just to see if something is consistent or if it's pretty inconsistent. Like, are you putting up the same results every game, or are you kind of all over the place? But we're going to do a little bit of review of our mean, median, and mode really quick. So we have two classes. We have class A with those following values, and we have class B with those set of values. And these are like percentages. So like a 73, for example, would be a 73% on this test, let's say. To calculate our mean, one sec. Okay, I guess I'll just. All right, so for the mean of our first data set, we're just going to add up all these values. So you would, in your calculator, you would do 73. Sorry, I was just pulling it up. So 73 plus 74 plus 74 plus 75 plus 76 plus 76 again, plus 77, plus 78, plus 78, plus 79. Just be really careful when you're typing these in. But for my median, I got 760, not the median, the mean, sorry. I got 760. And if you look, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 values. So we're going to divide by 10. So that would just be 76 if you work that out. For our median, remember, that's going to be your middle value. And there are nice that they're already ordered from least to greatest. That's always helpful. Since we have two values, remember, if you have two left over, you're going to add them together and divide by 2, or basically find the average, or what's between the two numbers. But 76 plus 76 over 2 is just going to be 76. If you want to simplify that. But remember, like, what's between 76 and 76? Well, 76, right? Our mode, remember, that's what number repeats the most often. So if you look, you have 274s, 276s, and 278s. This isn't something I mentioned a ton in our first set of notes, but you can have more than one mode since there's like a tie. So we'd actually have 3 modes, since those all repeat twice. And there's not, if there was something that repeated 3 times, that would be the mode, but since there's kind of a tie. All right, let's kind of repeat this process for class B really quick. So your mean, you're going to add up those scores. So 54 plus 55 plus 63 plus 65 plus 68 plus 84 plus 88 plus 92 plus 93 plus 98. And you're going to see it's coincidentally, we also get 760 when you add those all up. And if you count, there's also 10 scores. So if you divide by 10, you're going to get that these actually have the same mean. Interesting. We're going to find our median. So like I said, kind of work towards getting to the numbers in the middle or single number, but we have 2 because this is an even data set. So add these together, divide by 2. So if you do that in a calculator, 68 plus 84 is 152, divided by 2 is 76. So notice once again, we have the same mean and the same median between these classes, which I kind of did on purpose. If you look at this data set, none of the numbers repeat. So this one is an example of having no mode. And I put a question kind of like this on the Google form from yesterday. But keep in mind, if you don't have any numbers that repeat, a lot of times we say that there is no mode. So what I'm trying to demonstrate here, and I kind of did this intentionally, is I gave you two different sets of data that actually have the same mean and median. But so I want you to kind of notice that sometimes the mean and the median doesn't always tell you the full story, because these data sets are very different from each other. I mean, if you just look, I mean, like this is very, like these scores are very different than the scores in class B. Like in class A, it looks like everyone got a C, while in class B, we've got some Fs, we got some Ds, we got some Bs, we got some As. Like it's a little bit all over the place. While class A, it's pretty much everyone did the same. So this next question, which class did better? Defend your answer in a complete sentence. There's, like I said, a lot of times in statistics class, there's not necessarily a right or wrong answer as long as you can defend or justify it. So I could honestly see you arguing for either class. I mean, maybe class A, you would argue since everyone passed, that's better than class B, or maybe you'd argue for class B because it does have the highest score, even though some students failed. You did have some students that did very well and got an A. So kind of depends what you value or what you're looking for. It kind of depends what your data set's about too. Like the context is always important. But I would just say, I mean, I'm going to argue for class A. I don't know. I would say class A because every student passed. But like I said, you could very easily argue for class B. You could say that class B did better because it has the highest score, and who cares if people failed? I mean, like, should we really, like, I mean, or should we be settling for mediocrity? I mean, is it good if everyone got a C versus no one excelling? Or it kind of depends what you value or what you're kind of going for, and it honestly depends on the students. Maybe like maybe C's are really good for that class. Maybe that class tends to be in a lower average, or maybe for class B, like that's a, like maybe like if that was an honors class, like for example, or like a class where like the students all care about their grades, like I'm sure that would be not super great if some students are failing or getting D's. Like over half the class got a D or an F, which not good. So kind of, I mean, honestly, it's hard to say without a lot more context. But what I want you to see is that a lot of times the mean and the median isn't, it's not enough to kind of come up with it doesn't always tell you the full picture of your data set. So we can have completely two different data sets and have the same exact mean and median. So we're going to kind of come up with a new way to analyze our data or come up with a new statistic. Remember, a statistic is just a way to describe your data. It's like a number that's somehow describing something about your data. But so in this next question, it said, what else do we consider? Well, what I considered was the spread. Basically, how spread out was my data? Like class A, for example, has a very low spread. Like those scores are all pretty close together. They're not spread out. While class B has a higher spread, like those scores are kind of spread out a lot more. So we're going to talk about measures of variability. Basically, this is going to put a number on how spread out is your data. Or how spread out. And like I said, a very easy example, and we're going to kind of do it a lot in here, is look at different sports teams. Like if your score, like if you're looking at like a basketball team, let's say, like you're looking at their scores, if they're really spread out, that might mean that the team's pretty inconsistent. If some nights they're putting up a lot of points, but then some nights they hardly put up any. I mean, that might be a bad thing. I mean, there could be reasons. I mean, it could be the level of the opponent, things like that. But if you have a big enough data set, a lot of times you can kind of overlook some outside factors like that. You can kind of start focusing on maybe what's going on with the team, like if they're playing consistent or inconsistent, or maybe why they're having issues. It could at least start to answer some questions. So a standard deviation provides a way to, and sorry, I forgot to put a word here, to measure. Basically, it's your spread, or a lot of times I like to think of it as being like your consistency. And like I said, I will make sure I post a key to these notes. I know there's a lot of writing if you are trying to follow along, but there's kind of three things to keep in mind with the standard deviation. If you have a big standard deviation, that means that your data is really spread apart. So maybe you'll have some number, like maybe your data set would look something like this. This would be very, like this would have a big standard deviation because our numbers are very far apart, like 180 and 2000. Like those are quite far apart from each other. A small standard deviation means your data is less spread out. So like this might have like a small standard deviation if you had, I don't know, something like this. Like these numbers are relatively pretty close together. If you ever have a standard deviation of 0, that means that you have absolutely no spread in your data. So if you had a standard deviation of 0, that means every number in your data set is the same. Like this would have a standard deviation of 0 because these numbers are absolutely not spread out at all. Okay, so that's we're going to be calculating something called standard deviation, and basically it's going to let us kind of put a number on and how spread out our data is. And there's a lot of other things we're going to do with standard deviation, but that in the grand, like in the like and just the kind of the general idea of a standard deviation, it lets you kind of see how spread out your data is, especially when you're comparing data sets. So maybe I don't know, measuring something in the blood and I had female population and I had a male population. Well, I could compare the standard deviations. Maybe women, something in their blood is very consistent, but maybe with the men, it's more spread out or vice versa. Like, so a lot of times in the medical field, like, I mean, they'll use standard deviations to try and see kind of where there are differences in certain populations, maybe to figure out maybe, and then that might let them identify maybe why there might be differences or what's causing certain things in some subpopulations. So, I mean, statistics, especially in the medical field, can be quite powerful. I mean, they're used quite often to kind of in different studies or medical studies. So these are the steps to find our standard deviation. We're going to find our n. We're going to calculate our mean. We're going to kind of complete a table. We'll use that to find our something called the variance, which will ultimately let us find the standard deviation. So I'm not going to lie to you. These problems got a lot to them. Calculating standard deviation by hand is kind of a pain. Maybe when we're back in person, I'll let you guys use the graphing calculators to kind of see how to do it with like computer assistance. But I'm going to show you how to do it by hand because you might be in a statistics class where you need to do it by hand. But some statistics class will let you use a graphing calculator. And honestly, if they do, you want to take advantage of that because as you're going to see, it's kind of annoying to do these by hand. I'll be completely upfront with you. So we're going to look at 2 examples of finding standard deviation today. And these are the same data sets from the front of the notes. I know a lot of you guys don't have these printed, so it's not like you could look back, but these are the same data sets we found the mean, median, and mode to start with today. So the first thing you want to do is find your n. Your n is just how many numbers or how many things do you have in your data set. So I mean, you just want to count. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So if you just count like all those scores. Oops. This X with the bar above it, remember that's the symbol for our mean. So you would add these all up, divide by 10. But if you remember, we already did this on the front. Like this is class A right here. So we actually already know our mean. So I'm not going to recalculate it again. But I mean, you could just, if you want, add them all up, divide by 10. But we already did that on this note sheet. Okay, now we're going to work on this table. And this table can look a little bit scary, but once you get the idea, I mean, it's really not anything too crazy. So your first column, you're just going to list your numbers. So let me kind of see if I can write this as neat as I can. So I just write them in the order they're given to me. You don't have to order these from least to greatest or anything if your data set's not already like that. I mean, sometimes it might be helpful because if you have duplicates, that can save you some time. But it's by no means a requirement. So like, for example, if I swap some of these numbers I'm writing right now, it wouldn't affect my final answer. Okay, so your first column, you're just rewriting all these numbers in our data set. For our second column, if you look, what this means is you're going to take your X value and you're going to subtract the mean from it. So we're going to have a 70. So we would have 73 minus our mean. And I'm going to color code this. Here, let me just erase. I'm going to make my mean in green. So we're going to subtract 76. So, I mean, if you did that on a calculator, you would get -3. For this row, we're going to take our 74 minus our mean, which would be 76. You're going to get -2. And we're going to do that for the rest of our rows. If you have a duplicate, like see how the next row is just 74, I mean, that's also going to be -2. So 75, oops, go back to my color. And feel free, like when you're actually doing these on your own, I don't need you to write out your subtraction. If you just want to do it in your calculator and just in this box put what you got, that is totally cool. But 75 minus 76 would be -1. Sorry, I'm trying to color code this. Okay, and I'm just to save a little bit of my change, I'm just going to put all these -76s here because you're always subtracting your mean and your mean doesn't change. But we're going to do it for each one of our X values. So 76 minus 76 would just be 0. I mean, this one's a duplicate, so it's also going to be 0. 77 minus 76 would be 1. 78 minus 76 would be 2. This one's a duplicate, so it's also going to be 2. 79 minus 76 is 3. And let me double check the chat just to make sure there's not any questions. But if you do have any questions, feel free to throw them in the chat. And like I said, I know this can be a little bit tricky, but we'll be spending a few days on this as well. So to get our final column, if you look, it's basically what you did here, but you're going to square your answer. So like in your calculator, you do want to make sure you put parentheses or just make sure any answer you get, it should always be positive. But so -3 squared would be +9. -2 squared would be +4. -2 squared would also be +4. -1 squared would be +1. 0 squared would be 0. And this is the same thing. 0 squared would also be 0. 1 squared is 1. 2 squared is 4. This is a duplicate, so 2 squared once again is 4. 3 squared is 4, is not 4, 9, sorry. So you want to square your answer from the previous column and make sure you put parentheses, or just remember you're always going to get positive answers. You should never get a negative for your answer in this third column. Now that we've got this, we're going to add up all of our answers in this last column. So in our calculator, we're just going to add these all up. So it would be 9 plus 4 plus 4 plus 1. You don't have to put the zeros, but you can if you want. +1 plus 4 plus 4 plus 9. And be really careful when you put this in your calculator, because honestly, this is a lot of times where we mess up. So our total is 36. And now we're going to use this result to help us get to our standard deviation. So for our variance, our total is the 36. N minus 1, if you remember, our n is 10. So n minus 1, our 10 minus 1 would be 9. So 36 divided by 9 is 4. And then to get our standard deviation, we square root what we got. So the square root of 4, if you put that in a calculator, or if you know that, that would be 2. So our standard deviation would be 2. And that's how you find the standard deviation. It's definitely a process. And I know some of you guys are still looking at it, you're like, I don't know what the hell just happened in that table. Once it clicks, I promise you it really isn't that bad. But like I said, I'll be completely upfront. It is a pain to do this by hand. That's why I hope to show you guys, I don't know what, since we're not returning to March 1st, but I would like to show you guys how to do it in a graphing calculator, because basically you just enter in your data. It'll kind of basically do this table for you, so you don't have to do as many calculations, but I don't know how possible that will be, since we won't be in person for a while anyways. And honestly, even then, I don't know if I don't think I can pass out those calculators to multiple students in a day. So honestly, I'd have to find something else. But we're going to look at another example, and this will be it for kind of today. But you're basically going to be going through one of these on your own tomorrow. That's like what your assignment's going to be. So we're looking at this class B. So, and the first thing, if you count how many numbers you have, remember N is how many like numbers or how many things you have in your data set. But if you count, there's 10. And if you remember, we already found the mean for class B, like in this first part of our notes. So our mean is this 76. Like, I mean, you could redo it if you want, but we already did it. So why do it twice? Okay. So we're going to start our table. I'm just going to put those in the order they're given to me in my first column. All righty. And for my people that don't like to write a lot, I'm going to kind of show you how you can save a little bit of time. But remember, you're going to subtract your mean from each one of these scores. So like I'm really going to subtract 76 from 54. So 54, oops, minus 76 would be negative 22. But if you don't want to write that out, like this next row, I'm going to do 55 minus 76. That would be negative 21. My next row, 63 minus 76, that's negative 13. 65 minus 76 is negative 11. 68 minus 76, that would be negative 8. 84 minus 76, that would be positive 8. 88 minus 76 would be 12. 92 minus 76 would be 16. 93 minus 76 would be, just make sure it should be 17. Oh, it's just, okay, good. Would be 17. 98 minus 76 would be 22. So I don't need to see, like, if you look like the difference between what I'm doing here and here, I don't need you to write all that out if you don't want to. I mean, that's really what you're doing in your calculator. But if you just want to write what it equals, I'm okay with that. Because I know this is a lot of writing, and anytime you can save a little bit of time in this process that already is kind of annoying, that's always a nice thing. So to get our last column, remember, you're going to square all of these values. You're basically going to take negative 22 times negative 22. If you don't have a calculator that can do powers. But when you put it in your calculator, make sure you put parentheses, or every answer should be a positive. So if you ever get a negative, just switch its sign to a positive. But you're going to get some large numbers when you do this. Negative 13 squared would be positive 169. Negative 11 squared is going to be 121. Negative 8 squared is going to be 64. 8 squared is also going to be 64. 12 squared is going to be 144. 16 squared be 256. 17 squared going to be 289. 22 squared, our last one, should also be 484. So like one thing to notice is whether it's positive or negative, you're going to get the same answers. So your sign's really not important for that middle part. So like I said, you should always get positives, but we're going to add these up and be very careful when you put these in your calculator. Honestly, like I said, this is a lot of times where we make mistakes, like I do at least. So just add up each one of those numbers. So I did that and I got 2000, oops, not the highlighter. I got 2,516. And honestly, it might not be a bad idea to do this step twice, add it up again, and just make sure you got the same answer. Because, like I said, oftentimes this is where a lot of times, me, myself, and students, we tend to accidentally put in something in our calculator wrong. So I'd say it's worth checking this one twice. So we're going to take 2,516 divided by n minus 1. So n minus 1, or n is 10. So 10 minus 1 would be 9. So 2,516 divided by 9. And I get a decimal, which it's totally normal. I got 279. Oops, not 279. Sorry. 0.55. So I don't know, you can put a couple decimal places. You could round it to 0.6. I wouldn't round it too much, but definitely don't need to write the entire decimal. So I'm going to just put 2 places. And then to get our standard deviation, you're going to square root this. So do a square root, 279.55. It's roughly 16.7. So what the hell did we just find? Like, what does this actually mean? Like, what does the standard deviation tell us? Well, like I said, the smaller your standard deviation, that means your data is less spread out. So, I mean, if you look at this first class, we got a standard deviation of 2. If you look at these numbers, they're not very spread out. Like, they're all pretty close together. While in class B, like, your scores are pretty all over the place. You've got some Fs, you got some Ds, you got some Bs, you got some As, like, so you're going to notice there's a higher standard deviation than class A. Most of the time when you're doing standard deviation stuff, you're going to be comparing data sets. So usually you'll kind of compare the standard deviation between 2 sets. So class 2 or class B has the bigger standard deviation. So what does this mean? Like I said, that means that class 2 is more spread out. Or I like to think of it in terms of consistency, or class 2 is less consistent. So like I said, a lot of times we're going to look at like some sports examples. Like if you looked at a basketball team and they had a really high standard deviation for like their total points in a game, that would mean they're pretty inconsistent. Maybe some games they're putting over, like they're easily getting over 100 points, but maybe they have some games where they're scoring like in the 70s. Like, obviously, a lot of what it could deal with is strength of opponents. I mean, if you're playing harder opponents, you're probably not going to score as much, or vice versa. But I mean, if you could kind of, if you have a big enough data set, that would kind of take into account your strength of opponents, and you might see that maybe your team is just inconsistent. I mean, if you have a high standard deviation, you definitely want to ask follow-up questions like, why are there these games that they're scoring more or less? I mean, maybe it is just the opponent, or maybe your team just is inconsistent. Maybe, I don't know, maybe you just have good games, bad games, and how can you fix that? That's how I like to think of standard deviation. Basically, it tells you how spread out your data is. And I know these data sets are small. You could easily, like, I'm sure it's very easy just to look at class 1. Well, of course, that one's less spread out than class 2. But trust me, if you're actually doing an experiment or a study, you're going to have thousands of numbers. You're not just going to be able to eyeball it and be like, well, of course, this one has a bigger standard. Like, when you have so many numbers, it's hard to just look at it and see.